In this session, we will be looking at producing an idealized trace from single-channel recordings. This type of signal contains open and close times. We can extract and later measure these using a threshold crossing technique. The data here shows two ion channels recorded with a single patch electrode from a cell membrane. In this case, we want to extract the open and closed times, durations and amplitudes of these events in both channels. To achieve this, we will use threshold crossings to identify the open-closed states. From analysis, then open-closed times, we can select New Idealized Trace Threshold mode. Now we can set the time range of the sweep to process, as well as the levels above and below, which define the open and closed states. The levels to choose should be around the halfway point of the first channel. Having two thresholds helps reduce the detection of false events. Base level provides an amplitude reference for calculating open-closed thresholds in multiple channels. The two thresholds are averaged, and then the difference between this and the base level is doubled. This calculation provides threshold values for multiple channel openings. Transition points provides a dead time after an event, before another transition can be detected. This allows for settling of data which has been filtered. Baseline track sets the number of points to average to produce a current baseline level. The current baseline is used to set the level for closed events. All thresholds are shifted to match changes in the current baseline level. 0 disables baseline tracking, in which case the level of a closed event is set by the average value of the waveform making up this event. Interpolation sets whether the threshold transition time is the first data point after the crossing or interpolated. If unchecked, outward current becomes inward and the two threshold values are reversed. If we have multiple channel openings in the trace, as in this case, then select multiple level. Press New and the process dialog appears. Here we set which frames to process. Press Process and all frames are included in the result. A new channel labelled 201 has been produced. This is the idealized trace. Zooming into the overdrawn data, we see the idealized levels and durations of the open-closed events. Events such as these, which did not exceed the threshold levels, are not marked. Right-clicking on the data enables us to view and edit event properties. Clicking on an event, such as this closed level, populates the dialog with the event's amplitude, duration and flags. Flags show whether the event was open or closed, as well as indicating which level or channel it exists in. The idealized events can be dragged with the mouse. They can also be merged with the next event or split using the dialog. The dialog also contains buttons to scroll the screen, to jump to the next or previous event, and to fetch amp. This scans backwards to find an event of the same type and copy the amplitude of this previous event to the current event. Scrolling on presents the next page of events. When selected, an event's flags can be changed. Assumed amp indicates that the amplitude of the event is not an average of the raw data points. Any event flagged as bad data will not be included in any analysis. View Event List via a right mouse click produces a table of event durations and amplitudes. Color variations indicate opened or closed state. Now on to analysis. From the open-closed times item, we can produce open-closed time or dwell result views, as well as amplitude and burst histograms. The settings dialog for this amplitude histogram allows setting of min and max amplitudes to include. We can also set which state and levels are included or excluded from the result. Now we have a histogram of the count of events, binned with amplitude, each bin spanning 1.6 picoamps. Adding two vertical cursors now. I can use these as references for a fit to the data. To analysis and to fit data. Select the type of fit, the range of data to fit, and the channel. Now you can see the fit drawn on the data. As the type of fit was set to exponential, it has produced a straight line. For this data series, we can change to a Gaussian fit. So that concludes this basic introduction to single-channel analysis using threshold crossings. Later, we will also look at the more advanced scan event detection technique